All right, so as a review, this coming Friday, I don't know what day it is, 25th, Lab 2 is due. That ticket that I just posted on Blackboard, and for those of you that aren't in class, you should be able to get to that ticket by going to your calendar. If you go to your calendar, there you'll find on the 27th a ticket that's due. I decided to make it due on Sunday just because it's too hard for me, not too hard, it's just more than I want to deal with during the weekend to grade all your programs and grade tickets and do all the rest of that. So the ticket's due on Sunday at midnight, and I will try to grade it sometime during the next week.
You just created our own, correct?
Yeah, you just create your own, whatever it says, create something, right? You just create your own. And for that ticket, I think I did put that in the description of it. Let me see if I can find mine here. It's a discussion board, and your job is, can I see it? Is to read 2 chapters in the book. I'm kind of jumping it. What happened? Lost the description. I guess I should tell you what you're supposed to do. So let's try it again. I must not have saved it. Number 1, read chapters 14 and 15 in the book. While you're reading, either note or somehow jot down 2 questions that come to mind. It's very similar to the tickets I was giving you last year. I did some reading in RDD. Do the reading. While you're reading, come up with a couple of questions and email them to me. Well, instead of emailing them to me, please put them, once you're done with the reading, add them to that discussion board. And then to earn your second point, either reply to, maybe even answer one other person's question. At least one other person's question. So if you want to read a bunch of them and reply and have all kinds of great discussions online, that's up to you. I require at least one. 2 points for that, due Sunday at midnight. Questions? Okay. Let's see. I'm going to open up. You don't have to file here. This is just a little mini lecture. We're going to create a new project called classes if you want to start that. Otherwise, I'm just going to do a quick sample here. There was one thing that stood out in your assignments that I graded this weekend that I want to point out and make sure we get sorted out here. A couple of things from the assignments I graded this weekend. First of all, let's say that I should come up with an example here. Let's say you take a quiz. You get between, or let's just do the standard 70, 80, 90, 100. Okay. And we want to display your letter grade. So let's pretend that somewhere we've already calculated the percentage. So I'm going to create a final, please, double. Some of you have switched to these wrapper classes. We're going to talk about them briefly today. These are wrapper classes. All they really do is put a class around a type, a primitive type. And the reason you need to do that is when we use ArrayLists and when we use vectors, some of those things that are in my notes, if we're creating array lists, they can only store pointers to type or to classes. So if we want to store a bunch of numbers in an array list, we have to have some kind of a class, and that's all these wrapper classes are. For the most part, they work just like their primitive types. Just use them in equations, do like everything else, but make sure you convert to the right types. In my notes, it says you might as well use these because at least you don't have to worry when you need them and when you don't. They work very well. All right, so let's say I want to store a percentage, and I'm going to make that equal to 77. And now I want to determine what letter grade people get. So 90 and above is B, 80 or A, 8, let's try again. 80 and above is B, 70 above is C, 60 and above is D. So let's start with the first question. If the percent is greater than or equal to 90. And I learned something new, by the way. If you press on these keyboards, I believe it's Command Shift Enter, it finishes the line for you. So if you got like 6 parentheses you got to get past and you want to put a Control Shift Enter on a Windows keyboard, Command Shift Enter on these finishes the command. If the command is already finished, it moves you down to the next line ready to go. That saved me a lot of typing extra parentheses and semicolons and stuff. Then we could do something like TV append, you got an A. Then what? Well, then I want to ask the next question. Else, if, this is what I saw a lot of, if the PCT is less than 90 and it's greater than or equal to 80, right? So we said here, if it's greater, oops, let's do the percentage points, sorry. So this is what I saw a lot of on the homework assignment. And I dinged you and said, why are you checking for 90 twice? In your case, why are you checking for 400 twice? You're asking the same question twice. This says if it's greater than or equal to 90. If this is false, it's not greater than 90. It must be less than 90, and you don't have to ask this question. If you put these in the right order. Now, if you put them in the wrong order, that can cause some trouble. But here we can say if it's greater than 80, you got to be. Else, if it's greater than 70, at this point, it can't be 80, it can't be 90. Is it greater than 70? Is it greater than 60? And then finally, else, you failed. I can't let you leave here putting in those extra conditions when you don't need them. And if you write the code properly, set up the logic properly, this has eliminated everything over 90, so asking if it's less than 90 is redundant. Make sense? Aaron, the direction in your head just changed. You sure? First it was going this way. Pardon me?
That was something else.
That was something else. Okay. Any questions on that? And I don't remember, was it yours, Aaron, or something? No, it was Zach's, who emailed me back and said, but I didn't use 400. He said if it's greater than 400, greater than or equal to 400, or less than or equal to 400.
I never had an equal to. I just said if it's less than 400, it's
right.
affordable. If it's greater than 399 and less than 501, that means dangerous.
Right, but isn't the greatness? He said I didn't use 400 twice. I used 400 and 399. Okay, I can do that here too and say if the percentage is greater than or is less than 89 or less than or equal to 89. You're still asking the same question. Okay, so you have to be careful.
I never had the or equal to though.
No, but you asked the same question twice still. You just changed the number on one of them. You said, well, what about 399, which is just the one less than the 400. So everything, even a 90, in this case, an 89.99999 gets you a B. But that's a different concern. And speaking of rounding, there was another thing in there that said, draw me a little graph. Most of you got that figured out. And you said something like this. I'm going to do a final double payment equals 425. And then we used a for loop. And many of you did it this way. Not everybody, but many of you did it this way. Int I or whatever value, if the value for the value equals 1 or 0, and that made it even more complex. What do I really want to do here? I want to display 400 or 42, 43 dollar signs, right? One for every 10. What if this was 421? I still want 43 dollar signs. I wanted it to round up. I thought I made that clear in the assignment, but not everybody got that. Right. So what I want is 42 dollar signs. Well, if I want 42, I'm a human, I'm going to start counting at 1. The only time you start these for loops with 0 is when you're dealing with arrays that a computer generated that always start counting at 0. We humans, we count with 1, so I'd like to count with a 1 as long as the value is less than or equal to 421. I make that an integer. Yeah, I could probably do that. And then many of you did this. And this was not what I expected, but I had to start thinking about it. Okay, we're starting at 1 as long as we're less than or equal to 421, and this is really just that value up there. And then every time through the loop, bump it up by 10, so you get one of these for every 10. Okay, but some of you started at 0. Some of you had less than instead of less than or equal to. If you start at 0, you might get an extra dollar sign. If you have less than or equal to, you might be short 1 if it's exactly a multiple of 10. And my brain got so tired of thinking about whether it worked or not that if your program displayed 36 dollar signs, I said, good, you got it. But from a maintenance standpoint, this can get really confusing. What my solution to this would have been is divide this by 10, round it, and then use PMT here and just bump it up by 1. This makes a little more sense here, or at least to me it did, a little more sense to figure out how many dollar signs I want first and then just go from 1 to there by 1s. Yours worked. Most of them did. I think I got 1, but most of them worked. But on that example, what would happen? We'd have to test this thing how many times to prove that it works? Over and over and over again. I didn't want to think about it. The point was use a for loop, and most of you did. But your for loops, when they were bumping up by 10, really made it a potential maintenance nightmare, because if you're right on those fringes, you could be missing one or have an extra one. I could see it happening, but I didn't want to sit and think about when it would happen. In this case, this calculates how many I need. It should give me 43. So I'm going to get 42.1 to the ceiling means round up. So 43. And this would just go from 1 to, I don't know what there, 1 to 43. Now, if you prefer to start at 0 and go to less than payment, okay, I can live with that. That much I can figure out. The only time I use a 0 index is when the computer makes me. If I'm doing my own counting, I tend to start at 1. Because as soon as I print a dollar sign, that's not dollar sign number 0, that's dollar sign number 1, and the last one's number 36. Now somebody else asked me, how did I test this? How do I know if you had 36? I counted each little one, right? Not on my Surface, which is, by the way, what I had to use to grade your programs. My old crusty computer would not, it just fought forever to get through those Android projects. So I used my Surface, and it's pretty small. But I just wrote another for loop. I just did a TV append, a \n, and then I wrote another for loop that just said for integer I equals 1, as long as I is less than, and I just used 40 or something because I knew your test data was going to give me 36. So I use 50 here just as an example, I++. And then I simply said, what? Print it. Unfortunately, in order to append, you can't say, I just wanted to do I mod 10. I can't do that. That's a number. I cannot append a number, so then I cheated and said, okay, give me an empty string with that concatenated to it. And what this will print is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and as long as your last $sign lined up under a 6, that was good.
You actually approve this though?
Pardon me?
You actually approve that? If we use something like that?
If you did that for testing purposes, no, it's for testing purposes. You take it out.
Okay.
Okay. I wrote it just to test to make sure that you really had 36 without me having to manually count it. Copied this to the clipboard and pasted it into every one of your programs in the appropriate spot. So this one ends on a, where did it end? I didn't print enough. What did I do? You guys are supposed to be watching me. This should give me 43 of them. 10, 20, 30. No, here I went to payment. That's how many % signs did I get? That's what I wanted to know. I really want $signs. This just went too far to make sure I have enough digits to go underneath it.
You printed more. You printed too many.
I know. So I'm trying to figure out why. From 0 less than or equal to payment. Payment's a double. It should be an integer. Okay, so this is going to be a double. I could typecast it into an integer, I suppose. I just want to see what payment is. That's weird. I think the problem here is my font. Payment is 43, so that's what I was looking for. But these % signs and the 1s and the 2s and the 5s and the 1s, they don't line up quite right. So I think it's working fine. It's just the font here is not letting numbers line up very good. All right, any questions about those? It's just comments from your programs. Then what I would like you to do for today is start a new project. And I'm going to call this problem domain. Another request, I think everybody did it. Make sure you're using API 17 and not some other weird number. If you're using API 21 as your minimum, and I don't have 21 installed now, in order to grade your program, I have to download and install my 21 SDK, and I'm already up to 5 SDKs taking up room on my computer. So just stick with 17 and everybody should be happy.
What if my phone's a 9?
You can still run it as a, the minimum necessary to run it is a 17. There may be some features when you get really good, and that'll be after this class. All right. Then you can say, well, give me 19 because that's what my phone has, so I can use all of the specialty features that are built into Android at that level. But you can run an 8 app on there, a 17 app on there, anything, as long as it's not a 20 app, then you're okay. All right, while that's finishing up, I'm going to go to my notes and just kind of flow through this. This is the extended version of part 2, built-in classes. I'm not going to talk about vectors too much because they've been replaced for the most part by array lists, but they're here. A vector is a dynamic string or a dynamic array where you can add things to it. When you instantiate it, this is a class, when you instantiate it, you automatically get 10 elements, but you're not necessarily using them all. Gets a little confusing. A vector has both a capacity, which is initially 10, and a size, which is initially 0. I'm sorry, 5, because I said 5 here. If you use the default, it's 10. And then you start, just like we did with collections in Visual Studio, you just add things. So this says add the string Volker to that, or add a new string to that, add another one. You can just add as many as you want. When you add the 11th one and you exceed the capacity of the vector size automatically doubles. Becomes 20. So now you got room for 10 more. If you exceed 20, it doubles again, becomes 40. If you add one more, now you've got 21 out of 40. So still not terribly efficient because there could be quite a few extras out there. And if you remove elements, and you can from a vector, it doesn't shrink the capacity to accommodate you. Once you add enough stuff to it, if you remove it again, it doesn't shrink the capacity. So not quite as effective as the array list that we're going to spend most of our time talking about. Here's the discussion of wrapper classes. Their primary purpose is to wrap around the primitive types, like double, int, float, boolean. They have exactly the same name except for int. Int was expanded to integer. Everybody else has the same name with a capital letter. They are, as far as I can tell, completely compatible with their primitive types. But I ask you not to mix. If you're going to use these, and I recommend you do from now on, if you're going to use these types, stick with them. Don't revert back to the lowercase ones, except maybe for the counter in a for loop. The counter in a for loop is probably not going to be attached to a vector or an array list. There might be a little more efficient not to use a class as your for loop counter, but a primitive. Here's all the string stuff that most of you went through and did some nice examples on. I did look over a few of them. I just haven't put it in the grade book yet. For those of you who want commas in your numbers, hint, hint. I I probably saw in your homework assignments 4 different ways at least to format numbers. Decimal format is one of them. String format is another. A couple of you found a currency formatting thing that's built in and used that. That was fine. So nice job digging stuff up. Once again, there's 4 or 5 different ways to do the same thing. In your Part 2 lab, or in your Lab 2, you will need to use the calendar class because your loan now has a date associated with it. So you'll need to read this over, but I think it'll make a fair amount of sense too. If you have questions, let me know. There's also a date format class that formats dates so you can print them nicely. With weird formatting codes that'll probably show up again in JavaScript. I think those JavaScript formatting codes are really weird too. Okay, so here's the ArrayList class. Let's spend just a little time talking about this. Arrays are limiting, ArrayLists are not. Define an ArrayList very similar to the collections that we were defining at the very end. Nope, that's a different class. Sorry, we never did it. So let's do one of these. In order to define an ArrayList of a certain type, you first declare the class, ArrayList, and then in angle brackets, the type of each element in the list. So the downside, the plus side to vectors is you can throw anything in a vector that you want, any types, mix and match. In an array list, it's a strongly typed collection, meaning every element in the list has to have the same type. Give the list a name, whatever you want to call it, and then instantiate it. So this is its type. It's an array list of strings. And here we actually instantiate an array list of strings. Notice the parentheses. The parentheses basically say invoke the constructor. Now, the term constructor hopefully makes sense to you from a long time ago, but we'll review that again today. So let's see if we can make that work. Here's my project. Why is the screen gray? Something didn't go right. Let's try a build and see if it cleans it up. Did yours come up gray or is yours all right?
It says it's missing styles or something.
Yeah, I don't know why. We've been doing it, did all the other ones okay.
You rebuild or clean?
Either one, if it works. This one doesn't. I might try a run on this one to see what happens.
Yeah, build work.
Doesn't look like it's going to let me edit it.
Sometimes I've changed that app theme.
Change the what?
There is this app theme,
Here.
and sometimes if I change that to like holo light or something, it fixes it.
Thank you. Okay. A couple of you also tried having multiple labels and giving each one its own little pointer. That works. A couple of you said, I don't need to expand this. I can just keep throwing stuff on and it keeps growing on its own. Okay, except that the assignment says expand it. I just want to make sure you knew how. So it wasn't so much, you're not going to let me stretch it. What the heck is going on here? There, I moved it. Wow. Something a little funky with mine today. Okay, I'm going to park this back at the top and just use that technique where I keep adding on to it. So now I'm going to switch to the code. That's what we're here for anyways. We're going to create a method called run test, just like everything else. In a relatively future, not too far in the future unit, we'll learn how to actually lay stuff out and use these on create. So that's going to be a couple more tickets and more reading. I forgot to ask, do all of you have that $10 online book? John does. He can borrow his laptop and read it. A lot of you are nodding. You should have it. I mean, it's pretty cheap. You think you got a link either from Jason or from Bob when he was here showing you that book. I think it's a really good book, particularly the first bunch of chapters is a lot of background, maybe a little more background than we need right away. That's why we're jumping right into 14 and 15. If you don't have the book, let me know. And in here now, I'm going to declare my array list. And again, this is just for test purposes. So it's an array list. And then in the angle brackets, I have to type in what type of data I'm going to put in there. And this must be a class. So you can't put a little double in here. But you could put a big double in here, and that's fine. And that's why we have these wrapper classes, because in order to link them to these other classes, those numbers have to be tucked inside a class. For right now, I'm just going to use strings. And I'm going to make this a list of students. Now that's just a pointer. I could stop here. Now I have a pointer that points to nothing, but when it gets around to something, it has to point. It must point to an array list of strings. Typically, you'll see this immediately instantiated. And don't forget the parentheses. That finishes it up. Now, ArrayList is red. And I did send you an email this weekend saying, oh, cool, I found this cool thing that will automatically add an import statement for any class that you reference that is a built-in class. Automatically, as soon as you type it, it adds it to the import list. So now I got to remember where that was. I think it was Android preferences. Dig down about 75 layers. Was it editor? No, maybe. Somewhere it was code style. It's auto something. Build and execute languages.
It was under general somewhere.
Was it under general?
Yeah, try
System
general.
settings. There it is. No. Usage. I think it moved. Language injection to language? No.
It's under editor general.
Editor general, thank you. There it is, auto import. And I want to add ambiguous imports on the fly. I suppose we might as well optimize them on the fly. Why not? So what this should do now when I click on OK is it goes, oh, ArrayList, let me add that for you. And there it added whichever one of these makes it happy. There it is for the ArrayList. So instead of us typing those, it does them automatically. Why wouldn't you want that turned on by default? I don't know.
I suppose if you were copying and pasting.
Even if you copy and paste, it'll update them.
And you didn't want to bring in that class.
But then you can't run your code. So you just pasted something in here that you can't run, unless you've got names that are really close and you want to use your own version. I don't know. For us, that should work just fine. Okay, so now we have this student list that has nothing in it. We can add things to the student list. So we can say student list dot add. And then in parentheses, what string do you want to add? Normally, these might come off of a list someplace on the screen. They might come from user input. Maybe you've read them from an XML web file someplace. Who knows? But for right now, we're just going to add people to the list here. And since Reen's our guest, we'll put him in. And again, Command-Shift-Enter finishes that up. If you hit it again and it's already done, it starts a new line for you. It's kind of useless. But it puts the semicolon on the end if you forgot. Does a lot of cool stuff. Comes in pretty handy. And let's do another. Put me in so we don't insult anybody. And we'll put Jason in and call it good. So that's how you add them. Somewhere in my notes it shows you how to remove them if you wish, though that's a little less common. But it's in there. Now I want to display those. Well, first of all, I forgot to put a name on my little guy here. To give him an ID, I'll go back to my trusty dusty TV results. And then I need a pointer. Oh, I already forgot what it is. Find, that's what I want. Now I want to display them. I could use a regular old for loop. A regular old for loop, we would first have to find out the size. So I'm going to do an int. I'll call it num elements, I don't know, and set that equal to my student list dot, is it length or size? It looks like it's size. And then I could use that in a regular for loop. For int I, and again, here's where I'm using my primitive class in my for loop, equals 0. As long as I is less than the number of elements, bump it up by 1. But now I need to know, how do I extract an element from my array list using an index? Because this says print this one, then print this one, then print this one. So let's do the printing part here. Now I need something in here. Notice we don't get a syntax error here. It'll go to the student list and say, hey, you got a 2-string? If you do, give it to me. And it'll be some lame thing, probably. I suppose we might get lucky. Let's give it a shot. There's an interesting little feature. Notice I got reinvoker JSON 3 times. Because each time I said display the entire list, and the 2-string gave us this stuff in square brackets automatically. So if you just want to see what's in my list, we could have just left the loop out. I'm going to do a set text to clear out the old stuff. So that's a pretty cool feature. I had a suspicion it might be in there, but I have to try it. Whoever the genius was that wrote the ArrayList class gave us a 2-string. Stop. That automatically puts square brackets around the elements and displays them for you. Because these are strings, we can do that. Now, if I had an array list of student records, it would still work pretty good as long as each record had its own 2-string. So that's pretty powerful. So that means I didn't have to write the code to find out, give me one of them. But what if I wanted to change Volker's name to Karen's name for some reason? How do I get to that element? I know it's in position 1. Well, I have to go look in my notes because I don't remember. Can we use square brackets? Probably not. Okay. Here's a get. Retrieving an element from an array list, get, and then the index. So it's listName.get and then the index. Okay, that's not too bad. That legal? Doesn't look like it. Because I wasn't trying to get it, I was trying to set it and change it. Let's try a set. Index, and no, you don't. Notice here's my little prototype. That's what those are called. Tells us how the set function works. You have to give it an index and then what you want to change it to. All within the parentheses. And now if I wanted each name on a separate line without all the square brackets, I could use the get thing that we saw, or we can use a for each loop. And once again, I might have to go back into the notes, but I believe it was just a for, and then the type, and then a colon in student list. And I don't want student list, I just want that name. So again, remember how the for each loop works. It says for everything that's in this student list, make name point to the first one, the next one, the next one, the next one, but it's called name as you walk through. And this displays that name, so we should get them up and down and hopefully have Karen in position 2. Or 1, excuse me. I gotta click it twice. Oh, there it goes. Oh, pfft. Replaced it every single time. So here's the original version. Then in between I changed it, and then I displayed the final version using a for each loop. Array lists, for each loops, typically when you have an array list, you're going from the beginning to the end. Every single one you're going to process it so they work very, very well with a for each loop. So except for fixed lists, like in a business class problem domain, in a business class where you may have different, or you have a fixed list of acceptable values. Remember the constants that we had in programming logic intermediate?
Names of the month.
Pardon me?
Names of the month.
Names of the month, categories of movies, whatever you had. For those that are fixed, they're not going to change size. They're always the same. Arrays are appropriate. For everything else, you should be using ArrayLists because they're much more flexible. Questions? Okay, I'll leave that up there. Let's take a break, come back in 10.